Hey, Toby.
Hello.
How are you?
Good.
That's good. Hey, Aaron.
Can you hear me now?
Yeah, I can hear you now.
Awesome. I'm using a different computer right now, so it doesn't have a camera on it, but I can hear everything and stuff. And I can
That's
talk.
great, Aaron. So go ahead and get started on the on those two questions there.
Okay.
Hey, Freddie.
Hi.
welcome back. So you can go ahead and get started on those 2 questions.
Okay.
And then if you can send them to me in a private message, that would be terrific.
Okay.
So if you haven't done so already, please send me your answers. So I'll just give you guys just 1 more minute here. All right. So the answer for number 1 was equal to 134, And the answer to number 2 was 1,000. All right. So this is the schedule for today. We're just going to take up a few homework questions if anyone has them. Then we're going to be working into some transformations. The transformations, this topic is going to be just integrated throughout all of our, sorry, not all of our, but the majority of our chapters. So it is very important that if you have any questions with this material that you ask. Just because it is sort of integrated throughout the entire course, we'll be relying on what we learned for today and next week for each of those extra chapters. So, did anyone have any homework questions? No? Okay. All right, so transformations, what are transformations? So transformations are essentially just moving a graph. There are 3 types of transformations that we are going to be exploring. Can you guys just let me know if the text is large enough for you to see it? Yeah, that's okay. Noah? Toby? Okay, so transformations, again, are moving a graph. And the first type of transformation that we'll be looking at is called a translation. So essentially, we're taking the graph and we're moving it left and right, or moving it up and down. Okay, so fairly simple. The next type is called reflections. And as you would expect, it's just reflecting the graph over the x-axis, or it's reflecting it over the y-axis. Okay, and then the final type of transformation we're going to be going over is called compressions and expansions, and it's basically just changing the shape of a graph. So just to give you an idea of what that would look like, if our graph is just a parabola and we compress it in a certain way, then it might end up looking like this, where we've actually just compressed it by pushing in on the graph to make it change its shape. All right, so let's get into it. So translations, again, are moving a graph left, right, up, down, but the shape does not change. So as you can see right here, we've got a quadratic, which is y equals x squared. And then you'll notice that the graph is actually shifting up. So basically every little point on this graph is shifting up 1. And what I really want you guys to recognize right here is what's going on in the function. So in the function, there is a +1 beside the x squared. Okay, so I just want you to take a mental note of that the +1 is beside the x squared. And if we're looking at the function notation of this, the +1 is on the outside, sort of compared to down here where it's a -1 and it's on the inside of the brackets. So do you see what I'm saying when I say it's on the outside of the brackets? Okay, so I want us to just make some observations about this. So I want you to take a look at these quadratic graphs up here. And then I want you to take a look at these square root graphs below. So I want you to notice, okay, so this is being shifted up 1, and this is where the plus 1 is. This is being shifted down 2, and this is where the minus 2 is. And then I want you to actually compare that to when it's being moved left or right. So in this one, it's being moved right, but there's a minus 1, and it's actually inside the brackets. And then this one is being shifted to the left 2, and it's also inside the brackets and plus 2. Okay, so I want you just to let's take 2 minutes right here, and I want you just to make some mental notes of what you're noticing right here. Toby, here's my question for you. When we are moving the graph up and down, so in this case we're moving it up, and over here we are moving it down, where is that number situated? So if we're moving it up 8, where is that 8 going to be?
Right where the right in the center when the graph starts to turn the other way.
Right. Okay. So what you're describing right now is
Right on
8 is going to be up here.
X equals 0.
Right. I see what you're saying. So right up here is where it's going to be like this.
Mm-hmm.
So now where in the equation is the 8 going to be?
Right where the 1 is.
Right, exactly. And when we're just looking at the function notation, it's outside the brackets.
Mm-hmm.
Okay. Noah, what did you notice about the plus 1 and the minus 2? What kinds of observations could you make from that?
I noticed that when it's +1 or -2, if it's +1, it goes up 1. If it's -2, it goes down to like the whole graph. So
Excellent. Excellent. So that's telling us that, and it makes sense, right? Like that's what would be intuitive. If it's being +1, it's moving the graph up. And if it's -2, it's moving it down 2. So that makes sense. Okay. Aaron, down here is when we're moving it left and right. So what did you notice about when we were moving it to the right 1?
You'd add the negative number into the like the square root part of the equation, and it would put it over onto the positive side of the x-axis.
Got it. Got it. So basically what you're saying, Aaron, is that the two observations were it's actually directly beside the x.
Yeah.
Interesting. And then also you said that you're adding a negative to it.
Yeah, you put a negative in, and then it, like, since it's a square root or something, it flips it around.
Right, right. So it's actually sort of almost the opposite of what we would think is going to happen. right? Because we think when it's -1, it's actually going to be moving it in the left direction, but it's actually the opposite. So it's moving it right. And Freddie. So Freddie, what did you notice about when it's moving it left? And you are muted right now, Freddie.
I saw that the 2 became positive
Okay.
and it moved to the left.
Okay, so when it's a positive number inside here,
Mm-hmm.
it's moving it to the left. Okay. And so I guess what you're also saying, Freddie, is that the number is still right next to the x. It's still within the brackets, moving it left, right. Okay, excellent. Okay, so here is what we're going to just summarize. So what I would like you guys to do is just write down these notes because this is to act as a summary of what we just observed in the last slide. So, Toby, when there's a +3 outside of the brackets, what is that telling us? The graph is going to be moving in which direction?
The graph will move up 3.
Up 3. Excellent. And here would be an example of an equation where it's the x cubed function and then there's a +3 on the end. Noah, when it's y equals fx minus 7, what's happening to the graph there?
So we'll go down 7.
Down 7, exactly. And here would be an example of that. Notice how it's outside of the x squared. Aaron, what will happen in this one?
It will the x-axis by 1.
Sorry, did you say left 1?
Yes.
Perfect. Perfect. And again, notice how that +1 is inside the function. Okay, and then Freddie, how about this one down here?
So down here, it seems like it'd be to the right, 10.
That's correct. Okay, and then here is that -10 there. Okay, so let's get you guys more involved in this. Here's what I want to happen. Toby and Noah, you guys are going to each come up with a question, and then we're all going to solve it. Okay? So the two things that I want you to do right now, Toby and Noah, is I want you to choose a function. So it could be the square root function. It could be an x cubed function. It could be an x squared function, just any type of function. And then I want you to tell me 2 different translations that are happening. So whether it's going left or right and how many, and whether it's going up or down and how many. So when I say the parent function, that's just what I'm referring to as, square root. Okay, so Noah, I'm going to pick on you first. Noah, what is the parent function for yours?
It's the square root.
Okay, so y equals square root of x. And what are the 2 translations that are happening?
It's moving to the left 5. And we'll go up 3.
And up how many?
3.
3. Okay. And Toby, what's your parent function?
X cubed.
And left or right?
Left 1 and down 4.
Excellent. Okay, so I'd like everyone just to take 2 minutes and answer these 2 questions. So what we're looking for right here is what the function will be, what the equation will be when it's being shifted in these directions. And I would also like you guys to send your answers in a private chat.
Do you want them as like f of x or y equals?
You could just write y equals.
Okay.
And if you're looking for a square root function, you could just write it as that. All right. So just a couple things, just a couple very minor things to mention. You guys are doing really well with this. So the only thing to consider with this first one was that when we're moving it up, it is a +3 on the outside. Okay. And the couple things that I'll mention about this second one are that x cubed is what we call the parent function. So what that's going to look like is it's traveling left 1, which means it's going to be a +1 inside, and then it's traveling down 4. So the only things to mention here is that the cubed must be on the outside of the brackets. And the other piece is that in this second question, the parent function is x cubed. So there's not going to be like a square root in there or anything. They're two completely separate questions. Okay. Does anyone have any questions about this?
On the second one,
Yes.
since inside the brackets there's a 1,
Yeah.
it wouldn't make a difference if the 3 was on the x, though, right?
Well, it would actually, because what that is, the difference with that, Toby, this is a really good question. This is actually saying there's no need for these brackets anymore if that's the case, because the 1 is not being affected by the cube. So in other words, this actually drastically changes the graph.
Okay.
In that way. Does that make sense?
Yeah.
That's a really good question. That the parent function needs to cover the entire, like any translations left and right need to be within the brackets. It's sort of like with this square root, that the line of the square root actually has to cover that +5.
Mm-hmm.
Okay. Here's a different type of question that we could be asked. So in this one, they are asking about transforming a specific point. So if we have a function and we know that the coordinate 2, 5 is on the function, then how does that point translate or transform with these transformations being applied? So that's very wordy, but basically you're going to have to just figure out what's going on in this translation. So is it going left? Is it going right? Is it going up? Is it going down? And then transforming that point. So let's do the first one together, and then I'm going to have you do the next one by yourself. Aaron, what are the two translations that are happening in this one?
Is
Go ahead. Sorry, Aaron. It sounds like your mic is cutting in and out. Do you want to just use the text box, the chat box?
Yeah. It's hard to type.
You could even
That's so
just,
bad.
like if it's left, how many, or right, how many.
Left. Axes. There.
And then down 7, perfect. So Freddie,
Yeah.
when we have the coordinate 2, 5, and we are moving it to the left 5,
Mm-hmm.
where is that coordinate now?
Sorry, what was the question?
So when the coordinate is 2, 5,
Yeah.
and we are moving that point to the left 5,
Mm-hmm. The left of 5?
left 5,
Oh, left 5, sorry.
where is the coordinate now?
Sorry, you mean like replacing... Oh, like from this point. Oh, okay. Sorry.
That's
Okay, let
okay.
me just... Well, just -3.
That's
And
correct. -3
and then -2.
and -2. That's right. So what Freddie did there, everyone, was she just took the x coordinate of the, or the x of the coordinate 2, and she moved it left 5. So if our coordinate was right here, she's going to be moving it to the left 5 and then down 7. So the new coordinate is -3, -2. Okay, so I would like you guys to do question number 2 and then just input your answer in the private chat. All right, so great job on those questions, guys. Now we're going to be moving on to reflections. So as I mentioned earlier, translations were the first kind of transformation that we're looking at, where it's moving left and right, up and down. And here we're talking about reflections. So as you can see here, this graph is being reflected over the x-axis. So if here's the x-axis, there is the new graph. Okay? And I want you to understand, or want you to recognize where that negative symbol is. So when it's reflecting over the x-axis, it's on the outside of the function. And then when it's being reflected over the y-axis, it's on the inside of the function. Okay? So it's almost the opposite of what you would think. And the reason for that is because anything inside the function, so anything directly affecting the x, so like right here, it's actually making all of the x values negative. So if here was our original, it's now making this positive 1 negative 1. It's now making this function, this 4 or negative 4, and so forth. Okay? So really what you need to understand is that when it's being reflected over the x-axis, the negative is on the outside. And when it's being reflected over the y-axis, it's within the brackets. So here's what I'd like you to take some notes on. When the negative is directly beside the x, it's reflecting over the y-axis. And when the negative is on the outside, it's reflecting over the x-axis. All right. So I want Aaron and Freddie to give me a function and give me a set of translations or reflections. And then we'll all answer them as a class.
Okay. The first equation would be y equals x squared.
Okay. And what about translations and reflections, Aaron?
Yes. Then it would be it'll go over to the left 4 and up 7.
And what about a reflection?
So like which way it's going to reflect?
Yeah, over the x-axis or over the y-axis?
Over the x-axis.
And Freddie, I assume this is you?
Yes.
Okay. Okay, excellent. So what's interesting on this, Freddie, is that you're actually the parent function is actually already shifted, which is neat.
Yeah.
I'm perfectly fine with that.
Okay.
So it's right 6, up 2, and then reflection over which axis? Ready?
More of a, let's do y-axis.
Okay. Okay. So everyone, just go ahead and write down the the transformed functions. And then again, if you can send me your answers.
Mr. Easton, would you be able to go back 2 slides, please? I can see something.
Can you see that okay, Noah?
Yeah.
Are you
Okay,
okay if I
thank
just
you.
go back?
Yeah, thank you.
All right, so I'm just going to show you guys the answers for these two. And overall, they were really well done. So in this one, if we just look at the translations first, we'll see that it's the same thing as before. So it's going to be x plus 4, and then a plus 7. Now, when it's a reflection over the x-axis, that means we're going to be inputting a negative in here, and it's actually going to be on the outside of the brackets. Okay, so when the negative is on the outside of the brackets, that means it's a reflection over the x-axis. And one thing that I didn't mention, and I should have, so I'm sorry about that, guys, is that it really, it's not as much an issue for this one. The negative must be on the outside of the brackets, but there's something going to be coming up in this next question, so please pay attention to it. So in this second one, if we just deal with the translations first, you'll notice that this is already being moved up 3. So in other words, it's moving up 3, and then we're going to be moving it up 2 more. So that means it's moving up 5 altogether. Toby, can you just confirm that you can see off the side of the screen here? Okay, thanks. And then if it's moving to the right 6, it's just going to be x minus 6, like so. Now, the confusing part for this one as well was that it was over the y-axis. So when a reflection is happening over the y-axis, as we saw, oh, that's not going to work. As we saw before, the negative has to actually be inside the brackets with the x. However, what I didn't realize to tell you guys is that we can't actually put a negative right here. And I'm not going to explain why at this point. I'll explain next class because it's a bit more involved. But basically what we have to do at this point is we have to have a negative so we're actually inserting an extra set of brackets, but this parent function, this square, is still on the outside of both of them. So I didn't really write that very well, but I'll write it again down here. Okay. So because the reflection is over the y-axis, it needs to be on the inside of the brackets. However, as I mentioned to you just a few seconds ago, it cannot be directly beside the x like this. And I'll explain next class why that is. Okay. Does anyone have any questions about this?
Wouldn't putting it like that make it have a reflection over the x-axis?
That's a really good question, Toby. And putting it like this will still be over the y-axis. The alternative is if I put the negative out here, like outside all of the brackets.
Mhm.
That would mean that it's over the x-axis. So do you see how it can be very like finicky on where that negative is?
Mhm.
It just actually matters what this square, like what brackets the square is around. So if the negative is on the outside of all the brackets, it's reflecting it over the x-axis.
Oh, so it's because you need the negative to be applied before the square.
That's correct.
Okay, I get it now.
Okay. Does anyone else have some questions about this? Or would like it explained a different way? Okay. We'll just do one more. One more right here. Just give me a second here. There. The only thing to remember when we're transforming points with a reflection and a translation is that we want to do the reflection first. So it's almost like the same thing as order of operations, where we do brackets, division, multiplying, addition, subtraction. I totally forgot exponents in there, but anyways, it's the same thing with reflections. Okay, so reflections are first, and then translations after that. So in this one, this is being reflected over the y-axis, and it's going down 7. So here, when I've got the points 3, comma, -8, it's right there. And then when it's reflected over the y-axis, it's right there, which is -3, comma, -8. And then it's being shifted down 7. So that's -3, comma, -15. Okay, so I'd just like you guys to do this question, and then once that's done, you can have a break. So folks, just go ahead and have a 5-minute break, and then we can take up the question afterwards. There's a few different answers that we're getting, so we'll just take it up as a class. Aaron and Freddie, are you guys there? Perfect. Okay, so
Yes.
perfect. Thanks, Freddie. So again, the very first thing you want to do in these questions are just even writing down what the transformations that are happening. So the first thing is that it's being reflected over the x-axis, and then it's also being moved to the left 5. So if we look at our point here, our coordinate -6, 2, we are first going to be reflecting it over the x-axis, which makes it -6, -2. And then we're going to be moving it to the left 5, which makes it -11, -2. Okay, so this is our final answer, -11, -2. Does anyone have any questions about that? No? Okay. So what we're going to do in this one is we're actually going to take it one step further, and instead of transforming one point, we're going to transform a few different points. Okay, so if we have this as our function, this sort of rigid function here, we are going to transform it using this transformation. So the transformations are, first we're going to be reflecting it over the x-axis, and then it's going to be moving it to the left 3, and then it's going to be moving it down 2. So what we're going to do here is I'm going to give each of you guys a point, a coordinate. Okay, so Noah, you are going to be this point, -6, -2. And in a minute, you're going to be walking us through how we reflect it over the x-axis and then moving it left 3 and down 2. Toby, you are going to be doing this coordinate. Freddie, or sorry, Aaron, you're going to be doing this coordinate.
Okay.
And Freddie, you're going to be doing this coordinate.
Okay.
Okay. So Noah, could you talk us through this one? -6, -2. This is where we
Yeah.
start. What
Yep,
happens when we reflect it over the x-axis?
You reflect to the x-axis, the y value changes, so it would reflect to -6, 2.
Correct. And then you move it left 3.
That's -9.
-9, 2. And then down 2.
0.
Perfect. All right. And Toby, I believe you have -4, 2. So can you talk us through it?
So it would reflect to 4, 2.
Negative. Sorry?
Or no, that's the wrong way. It would reflect to -4, -2.
Correct.
And then move over left 3. So -7 and -4.
Perfect. Okay. And then Aaron, my next one, -2, -4.
So the first thing I did was you reflect the x-axis. So it goes from -4, -2 to -4, 4.
Oh, I'm sorry. You were -2, -4.
Yes, yeah.
Sorry,
So,
you just said -4, -4, I thought, but maybe I misheard you.
oh, whoops. Yeah, I don't know. Yeah, so I reflected it on the x-axis. So it turns into -2, 4.
Correct?
And then I moved it over left by 3, so it was -5, 4.
Yeah.
And then I dropped it down by 2 to -5, 2.
Perfect. Awesome. Great job. Freddie, you're next.
Okay. So my point would reflect to, hold on. A +3, -6.
Okay.
And then it moved to, hold on. Yeah, just hold on. Yeah, just to, yeah, +1, -8.
Sorry, you were at 3, -6.
Yeah,
And then where did you go from there?
+1, -8.
I think it should actually be 0, -8.
Oh, yeah, never mind, yeah, it's 3.
There you go. Awesome. Awesome. So then, of course, you just would connect the dots here. And there it is. Okay. So what I'm going to do right now is we're going to do one more graphing question. Except for this one, the original graph is going to be y equals √x. And then the transformed function is going to be y equals sorry, that's a -2 inside there. And notice how the minus is inside the square root. Okay, so just to give you a sense of the function y equals √x, it's at 0, 0, 1, 1, 4, 2, and 9, 3. Okay. Toby, could you just tell us what are the transformations that are happening in this one?
So right 2 and
Right.
up 3.
How about any reflections?
Reflection will be on the y-axis.
That's correct. And a reflection over the y-axis. Okay, and just a reminder to reflect it first and then translate. So I'll let you guys do this just on your own pieces of paper if possible, and then I'll just put up the answer in just a couple minutes. All right. So what I'm gonna do here, guys, just as I mentioned, we have the graph y equals square root x, and we're transforming it with these transformations. So what I ended up doing when I realized it was y equals square root x was I just graphed y equals square root x. So if you actually put this into your graphing calculator or Desmos, this is the graph that it would show you. So 0, 0, when you reflect it over the y-axis, it just remains 0, 0. Then when you move it up 2, or sorry, right 2, and up 3, that is your new transformed coordinate. Then if you start off at 1, 1, and you reflect it over the y-axis, it becomes negative 1, 1. And then right 2 and up 3. The next point that I have is 4, comma 2. And when I reflect it over the y-axis, it becomes negative 4, 2, negative 4, 2, and then right 2 and up 3. And for my final point, I've got 9, comma 3. I reflect it over the y-axis, which is negative 9, comma 3, and then right 2 and up 3. Then I just connect the dots, and that's what it looks like. Okay. Any questions on that problem?
I don't think so.
No. Toby, Aaron, Noah.
Oh, no, I get it.
Okay. Okay. So guys, you can really see how like we're basically taking what you would have learned previously, you know, because in grade 11 math you would have learned how to graph the square root x function, and we're applying these transformations to it. And so throughout the rest of this course, there's going to be a lot of graphing, and we're going to be applying these transformations to different kinds of functions. So we're going to be learning about cube root functions. We're going to be learning about graphing various polynomials. We're going to be learning about graphing exponential functions and log functions. So it really is integrated throughout the entire course. I have posted your homework. There isn't a lot of homework for today. There will be a lot more homework next week, so just prepare yourself for that. And also, I'm going to be adding in a couple more questions to the homework for today, because right now I only have number 1, number 2, and number 9 listed. But just keep that in mind that I'll be editing that document right now. So maybe even just check back within 10 minutes and there will be a few more questions listed there. Otherwise, if you guys don't have any questions, that's all for today. And I'll be seeing you guys on Monday. No questions?
No.
All right.
Thank you.
See you, Toby.
Thank you.
Thank you.
See you, Noah. See you, Aaron. Bye, Freddie.